Good morning, students. Today we are looking at the topic salts, and the objectives of this topic include definition and meaning of salts, and example of salts, and also types of salts. We have five major types of salt: the normal salt, acid salt, basic salt, double salt, complex salts. So these are different types of salts and their identification. You must be able to identify them and state their properties. And also you must be able to state the soluble and soluble salts. Soluble salt are salt that can dissolve in water, while insoluble salt are salt that cannot dissolve in water. You must be able to list and give example of soluble and insoluble salt. And also you must be able to know how to preparation of salt, how salt can be prepared, so whether for soluble or insoluble salt. And also you must also tell us how you can state how salt can be recovered from solution, either soluble or insoluble. Okay, you must also tell us how salt can be recovered from solution, and state uses of salt in industry, agricultural, preservatives, and so on. So now we shall be looking at salt and its definition. So the everyday salt is different from the salt in chemistry. In chemistry, you have many other salts than the normal common salt, the sodium chloride that you have. Sodium chloride is just an example of a type of salt. So let us now look at properly the meaning of salt in chemistry terms. A salt is defined as a compound formed when all or part of the ionizable hydrogen of an acid is replaced by a metallic or ammonium ion. So when hydrogen in the acid is replaced by metal or ammonium ion, the compound formed is termed salt. For instance, HCl in acid, HCl is hydrochloric acid. If the hydrogen in HCl is replaced by sodium, we now have sodium chloride. So the sodium has replaced the hydrogen in the acid. The new compound that is now formed is called what? Salt, which is what? Sodium chloride. Any metal can replace hydrogen. Okay, so and one of the way in which salt can be formed is a neutralization reaction. It is a product formed beside water when an acid reacts with a base. When acid reacts with a base, in a reaction that we call neutralization reaction, a salt is formed in addition to water. So now let us now see examples of salt that we have. The table shows the example of salt that we have. Now look at HCl, hydrochloric acid. If the hydrogen in the acid is replaced by sodium, we have sodium chloride. The next one, you have triiodonitrate acid, HNO3. If the hydrogen is replaced by potassium, the metal there, we have potassium triiodonitrate. And the third one is tetrasulfate acid, H2SO4. If the two hydrogen is replaced by zinc metal, we are going to have zinc tetrasulfate. So you can see from this table that the hydrogen in the acid is being replaced by metal to form salt. That is what we refer to as what? Salt formation. So now we will now look at types of salt. We have five major types of salt. So you need to identify them in a reaction. So we have the normal salt, acid salt, basic salt, double salt, and complex salt. So you must be able to identify the different types of salt in a reaction, and should be able to give example of these different types of salt. So let's look at them in detail. Now, normal salt. Normal salts are formed when all the replaceable hydrogen ions in the acid have been completely replaced by metallic ions. So in normal salts, there is no hydrogen left in the acid. All the hydrogen has been replaced by metal, and this has been shown in this reaction. When hydrochloric acid reacts with sodium hydroxide, the hydrogen there has been completely replaced by sodium to form sodium chloride. If you look at sodium chloride, there is no hydrogen left there. So we are only having sodium and chlorine to form sodium chloride. This type of salt is called normal salt, when all the hydrogen has been replaced by metal. So other examples are potassium triiodonitrate 5, zinc tetrasulfate 6, calcium tetrahydrocarbonate 4. These are examples of normal salt because there is no hydrogen in the compound. All the hydrogen has been replaced by metallic ion. So now look at the second type of acid. We call it acid salt. Okay, in acid salt, they are formed when the replaceable hydrogen ions in acid are only partially replaced by metal. So if all the hydrogen in the acid has not been replaced, is partially replaced by metal, the term acid salt. We are still having maybe some hydrogen in the compound that is formed. So, and this can only be formed by dibasic, tribasic, and so on. The basic salt cannot be formed from monobasic acid that only have one hydrogen. It can only be formed with acid that have two or more hydrogen. For instance, H2SO4 reacting with potassium hydroxide. Now, the potassium replaces one of the hydrogen in H2SO4. So now give us potassium hydrogen tetrasulfate 6. Now, if you look at this compound, there is hydrogen within the compound. That makes it an acid salt. Okay. Another example of it is sodium hydrogen tetrasulfate 6, sodium hydrogen triisocarbonate 4, and so on and so forth. You can look at this compound. They still contain an element of hydrogen within them. So this kind of salt is then acid salt. And this acid salt also they have property of acid in them. They turn blue litmus red, okay, because they still have hydrogen in them, and that makes them to be called acid salt. Now we now look at the another one, basic salt. Basic salt contains the hydroxy ion. So when acid salt contains hydrogen ion in them, basic salt, you recognize them when you see OH attached to the compound. You know that this is what? A basic salt. They occur due to insufficient supply of acid needed for complete neutralization of the base. So there is not enough acid to neutralize all the hydroxy ion in the base. An example: if calcium hydroxide should react with HCl, so you have calcium hydroxy chloride. So if you look at this compound, there is still hydroxy in the compound, and that makes it to be a basic salt because of the presence of OH that is present in the acid. And other example is zinc hydroxide chloride and other compound that you see there. One characteristic that they have is that they still have hydroxy ion attaching to the compound, and that makes them to be what? To be basic salt. And these basic salts, they still possess the characteristic of bases. They change red litmus paper blue because of the hydroxy ion in them. So the third type of salt, we call it double salt. These are salts which ionize to produce three different types of ion in solution. So these salts, they ionize in solution to produce three different types of ion, and two of these ions are positively charged, while the other ion is negatively charged. And they have the general formula M plus M3 plus SO4 dot 12H2O. Now the M plus there is they are monoatomic metal, monovalent metal that have a valency of one, like sodium, potassium, and so on. So while M3 has trivalent metal that have three valency, and they range from aluminum and most transition element, iron, copper, and so on and so forth. Okay, and these are general formula. When you see a compound that have M plus, M3 plus, and sulfate with molecule of water, you know that it's a what? Is a double salt. For example, we have potassium. This is potassium, aluminum, tetrasulfate hydrate. It contains 12 molecules of water. Okay, and there are other examples of double salt. These are examples of double salt that we are talking about. Now, having known that, we now look at complex salts. Complex salts are formed by mixing together two simple salts that result in the production of new ion called complex ion. So complex salts result in the formation of complex ion. They carry charges in them, and you have copper, tetramine copper 2 ion. the example of complex salt. So having understood that, now look at you have soluble and insoluble salts. Soluble salt are salt that dissolve in water, while insoluble salt are salt that cannot dissolve in water. You need to identify soluble salt and insoluble salt. All sodium, potassium, and ammonium salts are soluble salts. All nitrate salts are soluble salts. All chloride salts, except silver and lead chloride, they are the only one that is insoluble. All others are soluble salts. All sulfate salts are soluble, except calcium, barium, and lead sulfate. They are the only insoluble salts. And all sodium, potassium, and ammonium carbonate are also soluble, but all other carbonates are insoluble. So you must know the example of soluble and insoluble salts. So now we look at the preparation of salt. Salt can be prepared either it is soluble salt or insoluble salt. Soluble salt can be prepared by reacting dilute acid with metal, by reacting alkali with acid, neutralization reaction, by reacting dilute acid with insoluble base. These are methods by which soluble salt can be prepared. Preparation of insoluble salt, you can prepare soluble salt by a method called double decomposition, whereby two soluble salts react together. They give us one insoluble salt and one soluble salt. So the method that we use to prepare insoluble salt is what we call double decomposition. Or by combination of constituent elements, you can add the two elements together to give us the salt. And what are the methods of recovery salt from solution? Depending on whether the salt is soluble in water or not. If the salt is soluble in water, you have two methods: by heating to dryness. When you heat to dryness, the water will evaporate, leaving behind the salt, and by crystallization, by cooling. That's another method. And for insoluble salt, because they are insoluble in water, you can be removed from solution by filtration. You filter them and you remove the water part, the solvent part, whereby the solute that is insoluble will be left behind. And what are the uses of salt? Salt have many uses in industrial, agricultural, and consumer substances like chlorine gas, fertilizers, and laxatives. These are uses of salt. They are also used in food preservatives. Okay, they use salt to preserve food, drying agent, and antifreeze. That is the end of the topic. Question will be dropped in the noteboard. Thank you.